Hello students, today we will discuss excess pressure on a bubble. What is the difference between a liquid drop and a bubble? As liquid drop has a single surface, whereas a bubble have two surfaces. If we consider here is a drop, the liquid is filled on this drop, and here is air, here is liquid, and this is the surface. So a drop has a single surface. Whereas if we discuss about a bubble, the bubble have air inside, air outside, and a thin film liquid is filled in between them. So it will have two layers. These are layers, the one and two. Whereas here is only single layer, right? Now we already find out the surface tension due to the liquid relation with excess pressure for a liquid drop. That was excess pressure on a liquid drop was delta P is equal to 2T by R. Now today we will find out the excess pressure inside a soap bubble. Here is a soap bubble and the liquid is filled here. Air is inside as well as outside. If the radius of this soap bubble is R and the surface tension of soap is T, then there are two pressures, Pi that is inside pressure and Po that is outside pressure. The difference of this pressure is the excess pressure. Now, because of this excess pressure, the soap bubble will increase its radius by delta R. So initial radius is R and final radius is R plus delta R. This is initial radius and here is final radius. So the work done by the increase in radius is equal to force into displacement, and force is pressure into area and displacement is delta R. This pressure is excess pressure and area of the liquid bubble is 4 pi R square because it is a sphere and the displacement is delta R. This work done is stored in form of potential energy, and we know the potential energy is surface energy, and surface energy is equal to surface tension into change in area. Now our motto is to find out the surface energy first. The surface tension is T. Change in area. Change in area is equal to 4 pi r plus delta r square minus initial surface area of this sphere is 4 pi r square. But the liquid's bubble or the soap bubble has two surfaces. So we will multiply this equation by 2. Hence it is 4 is common, pi is common. So it is 8 pi t into r plus delta r whole square minus r square. If we open the bracket, it will be r square plus delta r square plus 2 r delta r minus r square. R square cancel out. As delta r is a very small quantity, so delta r square is negligible. That's why we are getting the surface energy is equal to 16 pi t r into delta r. This surface energy comes from this work done by the excess pressure. So we may equate these two one. Right? हमने यहाँ तक ले लिया है इसको. Then if we equate the equation 1 and equation 2, that is 4 pi pr square delta r, that is work done, and this is the surface energy equal to surface energy. This is work done to increase the area, and this is equal to surface energy. We may equate them. Then at the excess pressure P will be 4T by R. This is the derivation for excess pressure for a bubble. As the excess pressure is inversely proportional to radius, bigger the soap bubble, lesser the excess pressure, smaller the soap bubble, more the excess pressure. If we relate it is with the excess pressure for liquid drop and soap bubble, then the relation will be excess pressure for bubble is twice of excess pressure due to drop. And it was 2T by R, and it was 4T by R. This one. Thank you for that looking the